Hello everyone and welcome back to our SQL series. In last video we completed our foundation of joins, all four types of joins using our Venn diagrams and core logic. Logic has been clear. So today we are going to go deep on this topic. Multiple table joins, self join, union versus union all, and we are going to go deeper in this because these are the actual questions which companies gonna ask you in your SQL round. So in this video we are going to get job ready in terms of joins. So let's go. Now let's begin with the multiple table joins. So in episode 7, this last episode, we just joined two tables, customers and orders. But in real world, we need often three or more than three tables in just one query. So look at our database first. If I want to know which customer brought which product, then I need all three tables. The customer name is in customers, the product name is in product, and the link between them is orders, right? So here is the chain: customers, then orders, then products. These are the tables which we are gonna use for this. So customer ID links customers to orders, and product ID links orders to particular product. So now let's switch to our workbench and see the code here. So I have already just written the code and I'm gonna just explain you what this code says and what gonna output we get and how it is done. Okay, so if you just see the code, select C dot first name, C dot last name, P dot product, P dot category, O dot quantity, and O dot status. So CPO here stand for customer, product, and orders. We are just given an alias here, which is most required to keep our code short and clean. So from where? From customers, inner join orders O on. So we are joining table customer to orders based on what? Based on customer ID should be same. C dot customer ID is equal to O dot customer ID. Okay, so now customer table is linked with orders table. So now we will just use multiple join here. So one more inner join product P on O dot product ID is equals to P dot product ID. So now orders table is connected to product table and we will just order it by order date descending wise. Okay, so if you see the output, we got everything here what we needed to do this. So if you just go through the code, you can see first we join orders, then we join it to products. So customers, then orders, then products. What we did, we use multiple joins, we join multiple tables to get the particular code. So if we have a doubt like, okay, we just connected customers to orders and orders to product, so did we connected customers directly to product? So it does mean that customer is joined directly to products. The answer is no, not directly. The customer table is connected to product through the orders table. It is not directly connected. So you will get an output, but it will be interconnected, not direct. Okay. So that was a code for our multiple table joins. So there are few things which you should keep in mind that are required for multiple table joins to run successfully. First one is alias. Every table you should give an alias. Why? It will keep your code short and clean, easy to understand for everyone. Second will be prefix. Prefix every column. So like C dot first name is not just first name. It tells which table it is connected to. So prefix is always required. Third one, chain of the order. Chain of the joins in logical order. It should follow the data flow. You should always follow the flow. You should not put like A. If it is ABC, don't put it like ACB. Just follow the order and you will track it. Okay. Now let's do one thing. Now let's add group by to the code and we will get total revenue per product across all the orders. So this can also be your interview question, assessment question, everywhere. Okay, so what we will get here? Total revenue per product across all the orders. So I'll just switch again to workbench. You can see the code, right? So select P dot product name, category. We will just count order IDs. So how many times order has been placed we will get from here. We will just put it as times ordered. Then we will sum the quantity. So how many total sale items have been sold, we will get it as a total sold. Then we will just round up this sum of what? Sum of the product of price into quantities it has been sold. So we'll just get a total revenue. We'll just multiply the price and the quantity sold revenue. Okay, we will also mention it as total underscore revenue. From where? From products, right? We will just use multiple joins here. We will join orders on p dot product id is equals to o dot order id product id, and again we will inner join customers c on o dot order o dot customer id is equals to c dot customer id. If you just see the code here, you will get it, right? So we will group it by p dot product id, p dot product name, p dot category, p dot price, and we will just order it by total revenue descendingly. So we'll just get a top revenues first, right? So what this code is saying, how it works, right? So what it will do is, see, product is joined with orders using product id. So we find all the orders for each product, right? Then orders is joined to customers using customer id to identify which customer has placed those orders. So we will get orders, then you will get customers for those order. Then there is a one group by created by us for. So what group by will do? Group by is created, so it will just create one row per product and integrate the functions over there. We'll just calculate it. Okay, so we have used count, so it will just give us the number of orders. There is a sum quantity, it will give us the total units sold. We have sum of price into quantity, which will give us total revenue, right? So the flow here will be products linked to product id, linked to orders, linked to customer id, then linked to customers. Okay, again product and customer are not directly connected or joined, it is connected through orders. So we will get here, and you can also see the output as mentioned here, and this is a real life analyst query which we need to do. Okay, now let's move to the second one, which is self join. So what exactly self join is? Okay, so name itself, right? Self join, it is one, it trips people, but it is a simple concept. We just go through name. Okay, self join is when table is joined to itself according to name, just join to itself. So when do you need that? The most common example people give is like people's manager hierarchy. So imagine there is a table. In table you have manager id column refer to the rows in same table. So I will give an example. I will just write a code for it, then you will get it what exactly this query is and how the concept has been taught using this query. Okay, so if you just see this visual, we can get same table, give it two different analysis, e for employee and m for manager, then just join them like e dot manager id is equals to m dot employee id, right? So you like how same table different analysis, why, how, you will see the query, everything will be sorted. Okay, so without wasting time, just we will just move to workbench to get it done, right? So here I have already mentioned the code. What we will do is we will just create a small table known as employee with the employee id, name, role, manager id, and foreign key. So what is foreign key here? It is a manager id, it refers to employee id. So we have given a foreign key itself in a same table itself, right? We are giving foreign id as a manager id, which refers to employees, which is the its own table's primary key. Okay, so we have inserted some data. We can see here Rahul CEO manager id is null, so CEO doesn't has any manager above him, so he will be the one, no hierarchical above him. Okay, so he don't have any manager id, no manager. Okay, but if you see Priya and Ankit, VP sales and VP tech, have one written as manager id. So what this shows, it shows that Priya and Ankit have manager as Rahul. If you go to Sneha the sales lead have written as 2, so her manager id is 2. So what, who has employee id as 2? If you show incrementally, Priya has employee id 2. So we can clearly get that Sneha has manager Priya. Okay, so we did this manually using our logic and everything. Okay, but if we want a code for this, so we will just use self join, select e dot as employee, e dot role as employee role, collapse m dot name, no manager. Why we are using this? So why not anything else? Why this? So if in this case we can see our CEO, Mr. CEO Rahul don't have any manager, so we can just not write no manager, not null, anything, right? So what this will do is, wherever there is not any value, if it is null, then it will like no manager there. So that's the reason we are using it. Okay, from employee left done employees m on e dot manager id is to e dot employee id, and it is ordered by manager comma employee. So how this works and why it works? right? So what we have done here, we have used the self join method, one table linked with itself. And why left join, right? Why we have used left join here? Because left join ensures that all employees are shown, even if our CEO don't have any manager, we have null, then also it will show that value. So because left join ensure that every data is taken whether it is null or not null, so we use left join here, and we will replace our null value with no manager. That's the reason we use that. And how it works, so what the query will do is, the query will just match the employee's manager ID with another employee's employee ID. So it will just go there, it will just check, okay, this employee ID, sorry, it will go just managers, it will just take the manager ID of any employee, it will pick that value and search that value in employee's employee ID. It will match that and it will get that, okay, this employee has this manager according to name based on his employee ID. So you can see here the logic we used, that is correct. And Sneha has manager Priya based on her employee ID. We did it and we got it, right? So similarly, it is done, and we should know why we did it. So this is a, what we say, mostly in every interview or assessment you will get this question and you need to use this logic. That's where it is used. This pattern, employee manager hierarchy, comes across interviews very often. So just know it how it's done conceptually and you are good for it. Okay, next one which you are going through will be union versus union all. So names also suggest here a between. So union and union all does the same thing, it just combines two select statements. Two codes will be joined, combined using union and union all into one output, right? So what is difference between union and union all? If you see, I will just want a union card here. So union removes duplicate rows, it deduplicates the combined output. Slower because MySQL compares every row, removes the duplicate, it takes time and then give us the output. Whereas union all, what union all does, it just keeps everything included. It doesn't remove any duplicates, it keeps every data. That's the reason it is fast, because it skips the deduplication step faster, but not accurate, right? If you are just taking aggregation or everything. So there is one rule here. Both select statement must have same number of columns in the order and with the compatible data types. You can't just put union anywhere to just join the tables. It should match. If you're doing A plus B, the data in A and data in B should match. That is a simple one rule condition for this. So if we just switch to our workbench, I have written the code already as every time. So okay, we have here code for union, no duplicates mentioned clearly, right? So what we are doing is we are just selecting first name, comma city from customers, where city is equal to Mumbai. Same code we have, but where city is Pune, and we will just union this. So what happens in orders table or customers table, there is a duplication of rows many of the times. So why and how we do it? So what it will do is, union will just automatically remove all the duplicate rows. So it will take the same city name, sorry, first name and then city, and combine it in the both queries, and it will show it is as one. So first it will select all the customers from Mumbai, all the customers from Pune, then the union will play the major role. It will merge both the tables, remove the duplicates, and we have the output here, right? Basic rule, but very effective. Second one is union all. Union all has a little bit of big query. So I'll just explain you the query in short. This query combines customers having delivered orders and pending orders into one result. Unlike union, union all keeps all the rows, including duplicates, making it faster. So SQL is faster in this because it doesn't remove the duplicates, right? It doesn't check any duplicates. So how it will work? If you just see the query here, the first part says select first name, comma delivered as status type from customer C, inner join orders O on C dot customer ID equals to O dot customer ID, where O dot status is delivered. So we will get all the data with first name whose status is to be delivered, right? Same for the next query, but here the status will be pending. So what happens here is, so one customer may have order pending. Same customer may have one order delivered also. One may have pending also. One customer ordered 4 items. Two are pending. One is delivered. One is in progress. One is in cancel. Anything can happen, right? So here duplication must happen. So because what will happen here is, so if there are two products which are delivered, what it will do is it will just mention as Aditya the product and delivered. What about the second product, right? So we will just use union all here. So what it will do, how it works. First query return all the customers with the delivered orders, then second will give us the pending orders, right? What's union all will do? Union all will simply append the second result on the first one. It will give the delivered, then pending data after that, it will just join it, combine it, no duplication done on that, right? Then order by will do its work and sort the combined result alphabetically. Then we will have used limit here, so we will just get first 20 rows just to validate our data, and that's it. That's how it's done. And union all and union basic difference, union removes the duplicates, union all keeps all the results including duplicates, and that's it for this concept. Okay. Okay, so we are mostly done with this video. So here is a cheat sheet for this episode, right? So here you can see multiple table join. So what it does, it just joins the multiple tables, aligns every table, prefix every column. Things to be done, right? Self join, same table with two aliases, left join for the hierarchy, do it, done. Union deduplicates columns, rows, slower, and it is used for full outer workaround, right? Union all keeps duplicate faster and use when no overlaps. Here is a null trick, left join plus where, right? Key is null is equal to unmatched rows. And here's the key, when you use null, it should be is null or is not null. It should be never is equal to null, right? Just keep this trick in mind. And so here this was a full package for join, 2 episodes, every join type, self join, union, and everything covered. So in next video we will be covering subqueries. We will just writing queries inside the queries, right? Another massive topic for data analysis interviews, right? We will make it easy, don't worry. So like and subscribe and you don't miss our next video on subqueries. Bye bye.